Hey there, Nectartacus here. In this video, we're going to go over how to find and remove hard-coded passwords and secrets in a project. This could be useful if you're not quite sure if you've accidentally leaked some secrets into version control. So throughout this video, we're going to be going over this blog post that I wrote a couple of hours ago. Right now it's on localhost, but by the time that you watch this video, it will be available on my site. I'll leave a link to that one in the description. We're also going to be jumping over to a terminal, running some commands, and seeing how all these things come together. So yeah, throughout this video, we're going to go over detecting secrets and then a couple of different ways to address them or remove them, basically. And we're not going to be using any third-party services. This is going to be a combination of using grep as well as our brains, or at least we're going to try to use them. And yeah, there's a couple of different sections here that we're going to go over, but let's start with the top here, which is just checking some known files manually. So I've done a lot of contract and client work over the years, and I've looked at a lot of different code bases. And the files that you see here are some pretty common ones where I have seen secrets. They're not listed in any order. And by the way, for context, most of the web applications that I've built, or most of the applications that I do contract work for, are web applications. They happen to run in Docker, so no surprise that you see some Docker related files here, but nothing about this post is really specific to Docker. Your project could be doing anything. It doesn't even need to be a web application. But yeah, let's start here with the README file, or more generally any documentation files, because it is super easy to accidentally copy paste something here, such as a curl command that happens to have some API bearer token or some user credentials or something like that. So, if you're looking for some known files manually, give a look at your README file or documentation to see if any secrets are there. Next up, we have this .env.example file, and this is a very common pattern. All of my starter apps for Flask, Django, Rails, Node, and Phoenix, they all have this idea of a .env example file. And again, lots of different projects use this. The idea here is you can clone down this repo, copy over this env.example file to a real env file, and then you can just go and add your secrets to the env file. It's not commit to version control, and it's good to go. But yeah, I've worked with some clients in the past where there was all sorts of different secrets in here, and this is not a secret here. I'm just highlighting this one, and it was commit to version control. But yeah, I guess one other thing to think about here is when you're looking through this file or other files specifically is that, in this case, I actually do have a hard-coded secret of password here for the Postgres password. That's because in this case, we're running Docker locally with Docker Compose. Postgres is a running service in there. In development, I'm okay with having a password. I'm also okay with having this commit up to version control. I don't see this as being a compromised secret, because if I were to run Docker Compose in production, which I do quite often, and I do run Postgres as well, I am going to set a different password here in production with a different env file. I'm not going to literally have it with the password. So, there's one thing to think about, right? Is it actually safe to commit to version control? Then it's okay to commit to version control because you used your brain to determine that it's okay to do that. But I just wanted to call that one out there because, if you did glance through this env example file and you're watching this video, you may actually see this line and be like, wait, you've actually got a password hard-coded, but that's why it is there for that one. And then, yeah, another file to look into would be the Docker file itself here. So let's jump over to this file. This is a way to create a Docker image, is setting up the file system, installing all dependencies, and in this case, we're running gunicorn as well as whatever Tailwind and ESBuild and all these other things. But, this is a spot where you could accidentally commit some secrets here because, Docker has the ability for you to build in environment variables into the image here. I'm doing that over here. None of these are secrets, and that's completely fine. But, imagine in this case, if this were like a Stripe API key or something like that. So one, it would be a problem because it's commit to version control. Even if it's a private repo, you still wouldn't want that there. And then likewise, or second to that, once you build this Docker image, let's say you push it up somewhere, maybe you push it up to the Docker Hub, or I don't know, ECR if you're using AWS, or maybe DigitalOcean's private registry. Long story short, now your Docker image has that baked in secret there. So now your secrets were leaked to a third party. Hopefully they're doing things like keeping these images encrypted at rest, and, employees wouldn't have access to them. But do you really want to trust that with like your live Stripe keys, which is associated to taking payments for your whole like SaaS application or whatever you're building? No. So, I would suggest doing something different than hard coding secrets in an env. But they can also be in build arguments. They can technically be in a run instruction. They can be in a lot of different places in a Docker file. So, go and check that out. And then next up, we have the Docker Compose.yaml file. So let's take a look at that one. And in this case, there is a couple of different places that they could be. So for example, it could technically be in a build argument as like a default value like that. But in this case, there is this environment property that you can attach to a service like Postgres or whatever. And in this case here, yeah, you can just have environment variables. You can imagine if I weren't using interpolation here and I just had the hard-coded password right here, that is one spot that it can just exist right there. And by the way, we're going to go over some ways to address them in a sec, so I'm kind of skimming over all this stuff here. Another one is like the command property here. So I think I have an example of that down here where we're running Celery instead of Gunicorn here in this Flask app. It's just a background worker. But I've seen in the past where, someone passes in some command line flag to something else, not celery in this case. Like for example, Redis is a good example here. If you want to set a password on your Redis instance, it's pretty common to override the command and then pass in the password flag here. And you could theoretically just have a hard-coded password sitting right there. So, if you want to do that type of thing, we'll go over ways to address that in a second here. Another one is your Docker entry point script. Now, this file name is going to be super dependent on your project because it really can exist anywhere. But in this project here, I have a bin directory and the entry point is sitting right here. Now in here, there's like nothing sensitive whatsoever. This file will be executed when your container starts, like right before whatever process that you're running in your container does, if you have it set up like this. But in this case, you could theoretically have an API token here or something you just want to set at runtime, like an environment variable. But instead of reading from the environment variable, maybe you just have a hard-coded string here with something sensitive. So again, I would check that out totally. Then there's like just these idea of having assorted different config files. So this really will be dependent on what type of project you're working on. So maybe your application has a config directory or a settings directory or something like that. And this will actually, I think, be easier if I just go to the project here. So if I go to Docker Flask example here, and we take a look, I do have this idea of a config directory and a settings file in here. But yeah, you can definitely, or you should definitely, in my opinion, go through your entire settings file or config file and make sure that there's no hard-coded secrets in here because, if it's committed to version control, then things are going to be there. And, if you're using different web frameworks, like for example, Rails is a good example of this one, their config directory is a lot bigger. It's not just one file, right? You could have different environments. You could have, development settings over here. There could just be a hard-coded secret sitting right there. Or maybe in production, accidentally, you have one like right there, so I would check all these different files, especially application.rb, because, this all gets rolled into basically this idea of a config object, but, I'm not going to get into Rails specific things, but, I would go through every single one of these files in this project and just see if there's no hard-coded secrets. Great example here. Didn't even think about this one until now. Would be something like, your cable.yaml or database.yaml file. You don't want to have any hard-coded secrets here. And again, we're just falling back to that default password for the Postgres one. So it's convenient to use in development. That's okay to be commit, in my opinion. But yeah, that's just some examples here of assorted files depending on what framework you're using, right? If you're using Django, maybe you have a config directory that you've set up, go check it out there. If you're using Laravel, go check it out wherever Laravel saves it, et cetera, et cetera. So yeah, for every single one of these files listed above here, I would go through every single one of those files line by line, just looking to identify some potential secrets that could exist. Hopefully this detects, right, most of the ones that are leaked in your application here, especially if your application was coded in such a way where all these config values are really only read in one spot, right? Basically just in that config directory or settings file, whatever it happens to be. Hopefully you just don't have hard-coded references to tokens just sitting somewhere in an HTML file, but you never know. And that's, why we're going to go into some other ways to detect this stuff if you don't know where to look ahead of time. By the way, I've written about the importance of like defining config options in one spot. I'm pretty sure I did make a video about this one. Yep. So I'll leave a card to that one if you want to check it out. It just goes into, the value of doing things like having your envs be read in your config directory and then, only being read there once in one spot. But yeah, if you're looking for ways to address all of the above with the README file, if you were to have something like a curl command where you had some API credentials there, don't just hard code the credential there. Put a reference to the environment variable name. If it's like API underscore token, just put like an, $ API underscore token or something like that. And then, someone can source that env file, run the curl command, and then they're good to go. And then for the env example file here, I would suggest storing sensitive values in a secret store or basically anywhere outside of version control. This is really dependent on how you want to have these things stored here. For example, well, I don't know, I was going to say, like, for example, like AWS has their own secret store. You can store them in an encrypted S3 bucket. Like, there's many different ways that you can store these secrets here, depending on, what your infrastructure is like, how your organization wants to run them, what you're doing personally, because maybe it's just you. Maybe you just have the file on disk on your laptop or DevBox or whatever, and that's it. That's totally fine. It's use case dependent here. But also, there's this idea of certain web frameworks, the way they handle secrets. For example, Rails has encrypted credentials. So you may want to look into that, if you're using Rails or, other frameworks may support the same idea here. And when it comes to the Docker file, if you really need to have build time secrets, meaning like, an API key needs to be available so you can, pip install something from a private Git repo, but that private repo is protected by an API key, so you need that at build time, then using something like Docker secrets, really great idea. So I've linked to references here, so you can go and check it out on how to get a resolution on that one, because we can't really go through this entire blog post in this video, because then it becomes a whole video on, Docker secrets. Maybe I'll do something like that in the future. And then, I just threw out a second bullet here, like basically whenever possible, try to make your secrets defined at runtime. So you can just set an environment variable when the container runs, and it doesn't need to be built or, made available at build time during your Docker image, because the idea of the secret here is, or I guess I should say one idea of using Docker secrets instead of build arguments is even if you were to use a build argument where you're technically not committing the secret to version control, when you build your Docker image, it's still going to be in the layer, whereas with Docker secrets, it won't be. So there's a lot of good stuff behind Docker secrets. I would recommend checking it out. And then, when it comes to something like the Docker compose.yaml file, there's two different ways to solve this problem here. So I wrote one, if you have a whole bunch of environment properties in your Docker file or your Docker compose YAML file, for example, going back to what we saw over here, if you just had a whole bunch of different hard-coded values here, you may want to consider just using an env file reference here instead. So for example, the main application here in this Docker compose YAML file, it just uses the env file here, and then it just references the env file like this. So all the environment variables are just tucked away in a single file. We don't have to have them all defined here in the environment property. Now, there is a case where, why I do want to have this environment property here and not an env file for Postgres. I'm not going to get into that in this video. I actually think I may have done a video about that one in the past. If not, I definitely did a Docker tip about it. Whatever, I'll link that one in the description if you want to check it out here. But if you don't want to use the env file and you want to have referenced environment variables like this, you can just use variable interpolation. This is a feature of Docker Compose. It works very similar to how it works on the shell, although it's a little bit different in subtle ways. But you can see here, you can reference an environment variable and then set a default value, in this case 0. So yeah, you have options here to avoid hard coding things into that config file, the Docker Compose YAML file, I mean. And then when it comes to the entry point script, yeah, just instead of having hard coded values in there, just go and reference environment variables or whatever mechanism you use to load in secrets. And the last one here, when it comes to those assorted config files and settings and, whatever directories and files that may have secrets there, yeah, just extract those out into environment variables, or again, like whatever secret store mechanism that you want to use. Okay, that takes care of what, in my opinion, is like the low-hanging fruit. These are just like common areas where you may actually know something exists. So let's go look at it and address it there. But now that the low-hanging fruit is kind of handled here, we can actually search through the code base for well-known strings that might have sensitive information in them. And that's basically what this grep command is over here. So this is going to perform a recursive regular expression case insensitive search here for known values. So the -r here is recursive, the -e is extended regular expressions with grep, the lowercase I is going to be case insensitive. We're going to ignore the .get directory. I also threw out his comment here. If you want to use get grep instead of grep, that's totally fine. But yeah, the idea here is we're going to look through all these files in this whole entire project, and we're going to look for certain words that exist. So auth, authentication, authorization, bearer, secret, token, password, and username. These are all different things that I've found in the past where it actually did find matches here, right? Because maybe you have a bearer token. Maybe you just have literally a variable called password equals. And then, yeah, there's all sorts of different ways for this to come up here. And by the way, I threw out here, you can technically include the O flag here if you just want to show the matches here. But yeah, let's actually run this command against one of these directories just to see what happens here. So this is the Rails application here. So I'm going to run this one here. And this is actually a great example of something we're going to get into a little bit later here. But man, you can see this thing is just like going through a billion cache directories here. And I really don't care about the secrets sitting there in cache directories or like the build output directories. So we're going to go over ways to make that a little bit nicer just by ignoring those things. And yeah, I guess you can't use less like that. But in any case here, we can see that it is scanning for words or strings that have very specific words in them. For example, look where my mouse is here with this README file. Credentials are removed, secrets. So if we go back to the blog post over here, we can see that the word secret was included as part of that. Now, I do go on a little bit later here that there's other flags that you can use to tighten this up a little bit. I'm actually going to do this in the Flask one just for now because, yeah, this Rails one, there's just a lot of noise just for this example here. So let me go back to the Flask application and I'll just rerun the same commands here. Yeah, much better, a lot easier to manage with here. I don't need to pipe it to less and we actually get syntax highlighting or, we can see the different matches a lot easier here. So in this case, it's kind of funny, right? This is a lot of false positives coming up here because about the author. Well, the word or the word author has auth in it, and that was one of our words. There's secrets. But, these are all like major false positives here. So what we could do is we can tighten this up a little bit too, right? Just by putting like the -w flag, which is going to match whole words only. So in this case, we can see that, yeah, look, if we didn't know to look in that settings, that py file, we would have found potentially a hard-coded password. In this case, it's totally fine because, we chatted about that before. This one's okay, but you can see how it's pretty helpful in identifying where you might just have things. But yeah. So going back to over here, just going through the blog post here, blah, blah, blah. The above, right, it's not going to catch everything, right? But I have really honestly lost count track of how many times I've picked things up here just by this regular expression here, like easily 20 or 30 different passwords across a couple of different clients here. But, usually it's something like a bearer token or an API key. Username is thrown in there just because, like, on more than one occasion, the username actually was the password. So, it wasn't good to have that commit as well. And, I did mention here too, like, theoretically, the way it was without the -w flag, auth authentication and authorization and pass and password, these could have been rolled up into just auth or pass, right? Because it's a regular expression and the word auth is in all three of them in this case and pass is in both of them in this case. But yeah, I wanted to explicitly list them out because one, it's kind of nice just from the intent perspective, like, these are three distinct things that you wanted to check. But again, like, just adding that -w flag, just allows us to match on these whole word only matches here, which is pretty nice. Since they're explicitly written out here, we can just drop in the W flag whenever you want here. And, just in case that wasn't clear with the -w, for example, if we didn't use -w, then we would pick up things like secret token with a capital T here, which you may actually want to choose. That's why I didn't put -w here by default. So I really do think it's worth running both variants against your code base, and then you can just use your brain to determine which ones you want to keep or not based on, whatever you find here. And, between this and the previous section here, I think that's going to catch a lot of stuff, but this is not bulletproof because, for example, what if you just had this sitting in your code base somewhere? Like, this is not going to pick this up because none of these keywords are in this match here. And, this happens to be a Postgres connection string where you have the username, colon, and then the password, and then the host as well as the database and, whatever. There's other things that you can put here, like the port number. But, our above regular expression up here is not going to catch that. And, in this specific case, like hopefully, this would be in your config directory, in which case actually for the Flask example app, it happens to be in my settings file here somewhere. Yeah, there's the Postgres connection string. It's also, providing the adapter in there, but, it's a user and the password, and these all are being read from environment variables. So, none of that stuff is hard coded here. But yeah, this could have been theoretically in a completely different file. Like, I don't know if I had like a database.yaml file or something and it wasn't in the config directory. Personally, I wouldn't do that, but if that were the case, then yeah, we're not going to find it here or here. So now there's like some other stuff that you may want to do here just to, identify where in the world secrets can actually be located here. Because yeah, like I mentioned before, the above two methods are pretty good, but maybe you're working on a 12-year-old project, maybe 20 different developers worked on it. They all had different types of experience, and who knows what someone was thinking back in whenever it was, 2011. Maybe you didn't have a really refined code review process back then. Maybe there's, secrets being leaked elsewhere, such as like comments right above an API call. Maybe you just have tokens sitting in your test, like unit tests or integration tests or whatever, and you didn't think to read them from a environment variable or a config value instead of there, so you just like dropped it in as a hard-coded thing, right? All of this is going to be super app dependent, but you can scan your whole entire code base for strings that might have sensitive information. But it's like, well, before we get to that regular expression, like what should we even look for? Like what criteria are we even looking to even achieve here? So for example, maybe the criteria is just like any 12 characters that appear in between single or double quotes. It's going to create probably a lot of false positives there, but it's better than nothing. And I think we can tighten it up to make it a little bit more user-friendly here. But yeah, if we didn't do anything else besides this, like imagine you just scan like some HTML template, like a view file or something like that. Literally this would be a match because this happens to be, I don't know, over 12 characters long here, 16 characters, because, if we're going with any 12 characters or more wrapped in single or double quotes, well, this is wrapped in single or double quotes, right? And it's more than 12 characters long, so it would be a match. And if you wanted to get cute here and ignore values that have a / because you could be like, yeah, well, I don't want URLs, they're going to be long. I don't want them to match. I don't want, asset paths to match or whatever. Then you might actually skip legit tokens here because there are certain algorithms that do include / in them, and you probably wouldn't want them skipped. So This is really now dependent on the size of your code base, but I would suggest going for a little bit more of a specific search to begin with. Otherwise, you can have way too much noise, way too many false positives here, and you can always loosen things up a little bit later. So maybe now we can refine our criteria a little bit to be something like, any 24 non-space characters wrapped in single or double quotes, and the very next character after that should probably be either like a space, a period, a semicolon, or maybe the end of the line. So this second rule is going to help reduce a lot of noise, but variants like this is going to, be picked up. If you had something like a JavaScript file or whatever, some token that was spelled like TOK like that, this now has a semicolon at the end. This one has a new line at the end. This one happens to be a string concatenation in PHP with a period, and this one happens to be the same thing but without a space. And, if this were a secret token, then that regular expression would match all these, and we would actually be seeing, we would see those. But at the same time, if you just had like an image tag set in an HTML file or whatever template language that you use, then this is not going to be picked up because, right after that last quote there, we have a greater than sign, and that's not one of the next characters that we want to look for. So instead of being noise, it won't get picked up, which is nice. So yeah, also depending on which framework or tools that your app is built with, there's probably going to be a whole bunch of different directories that you want to skip because they're going to be filled with like massive false positives and like some really annoying output that we're going to see in a second here. But yeah, for example, it's probably safe to skip your CSS directory, right? Because maybe you don't have secrets stored into your CSS, or I hope not. But when it comes to something like client-side JavaScript, yeah, I've totally seen secrets accidentally be pasted there because someone, took a snippet from somewhere and they pasted it into their JavaScript in like a script tag somewhere, and there it is. And instead of extracting that out to an environment variable and then looking at, maybe putting that in server side into a data tag or data attribute onto the HTML element and then reading it from the JavaScript, it just stays there. And yeah, so I would highly suggest keeping a lookout for your client-side JS there for secrets. But yeah, you can also exclude a whole bunch of directories and files there, depending on your use cases, right? Because again, like we saw with the Rails example there's a temp directory has a million different potential cache files in there or build outputs that could exist in other directories. And you don't want to have those scanned because these are usually really annoying false positives because, I don't know, like a minified cache file might just be a JSON file with like a really lot of long strings, and the output of what you're going to see in the terminal is just like an endless sea of characters that you just don't want to have to look at. So I would definitely use exclude directory pretty frequently depending on whatever framework that you're using. So we kind of went over our rules on like what we actually want to do, but now let's actually do it. So what in the heck is our grep command actually going to look like to make this work? And by the way, I should point out that the solutions that we're going to use here, they are going to work on both the GNU and BSD versions of grep, which means they're compatible with Linux and WSL2 and macOS and all that good stuff. So you should be able to copy paste this. And I don't know, for some reason, if it doesn't work on some version of macOS that you have or Linux or whatever, let us know in the comments below and I'll tweak the blog post to actually make them work. And I kind of just included a couple of different excluders just to demonstrate that you can exclude more than one directory here. But yeah, these are the same flags that we looked at before: recursively, extended irregular expressions, and case insensitive here. But yeah, these are the, this is what I would say is the tighter version, so less false positives here. It's going to account for both of these bullet points here. Whereas the second one here is a little bit looser. So it's not going to, instead of doing 24 characters, it's going to do 12. And it's also not going to account for the second bullet point up here. But yeah, let's break this thing down a little bit before we start to run it. And I think it's going to be a little bit easier because you just look at this and it's like, yep, that's a lot of characters and I don't know what anything does. But it's really not that crazy. Well, for regular expressions at least. So, if we break it down, using the parentheses like this, it's just or basically. So it's either a single quote or an escaped backslash. So that matches single or double quotes here. And both of them have that in common here. That's how things start off. And of course, we're wrapped up here with double quotes just to quote the entire expression itself. But yeah, so we have that. And then we have, backslash capital S 24 bracket, blah, blah, blah. This just matches any 24 non-white space characters. And now I think it's probably a good idea to maybe run this and see what the difference is between that, because that's a little bit confusing. Not super confusing, but let's get into this and run some stuff. Actually, let me clear that so we have a full screen. But if I run this here, we can see that it is matching all strings here that are non-white space and they have more than 24 characters or 24 or more. So in this case, it's kind of interesting because there's SVG files here that have some matches on URLs. Maybe that's something we can exclude instead. But in this case, we can see that we're clearly getting matches. There's no spaces in these matches here. And if I didn't put that, I'm probably going to be blocked, hold on. If I didn't put that \s there and we put a dot instead, which is going to match anything, then we are going to start to see matches where spaces are included, because right away we can start seeing like, okay, we've got this match here in the middle, but look, there's a space there and there's a space there. So chances are, technically it is possible to have a password with a space in it, so maybe you should run both variants. But in this case, it's pretty uncommon for a password to have a space. So I do like using the \s there, to have that set up. And so let's go back to using \s there just as one more time so you can see the output. Look, no spaces. But if you just wanted to do a search for things that are, 12 characters instead, you just change the 12 or 24 to 12. If you want to do 64 or 32, you can just change the number there and you're good to go. So let's go back to unwinding this regular expression a bit here. And thankfully, there's really not that much more, because the other rule here, which is this up here, is literally the same thing as this one. So we're just looking for matching a single or double quote. Now, I will say this is not perfect, and I'm going to go over some of the, flaws in this method here, but it's pretty good, I find, at least in my opinion here. But the last section is this section over here, which is the second bullet point that we were chatting about before. So, let's match any space-like character, period, or semicolon, and this \s will actually match new lines as well. So we are in a good position here to see how all the stuff works. So let me go and grab this, but let's actually just use a loose one instead, like just because I was going to backspace that stuff out anyways. But we can see already, like, this is starting to produce a lot more noise here. It picked up this URL here. Why? Because, going back to what we mentioned before, this greater than sign is not part of what we wanted to match on. And, now we're not even matching on that, right? We're matching on 12 non-space characters wrapped in quotes. And that's why we're getting all these different ones that, in my opinion, are just noise. Like, these are not really going to be secrets. So that's why I like the tighter one. But still, before you pull the trigger on something, you may want to do both versions here and compare both of them. If you want to just hack away on a regular expression, regex101.com is really good, because you can put your regular expression in here. For example, let's just, grab the loose one over here, pop this in, and then you can just start writing your test cases here. Like, you can see this is not matching. Why? Because they're not matched they're not in quotes here. But if I put quotes there, then that one matches. So this is really nice to have real-time feedback in how some of this stuff works here. So I do suggest checking that one out if you want to build this up or tweak it a little bit for your liking here. But I do want to mention that, this is not perfect, because it will match unmatched quotes. Because, for example, this regular expression is looking for a single or double quote and then all this other stuff, and then, a single or a double quote. So if you had something that was like a single quote, 24 characters of whatever, non-space ones, and then you had a double quote here, that's a mismatch of your quotes, right? For example, if you had something like this is going to be a mismatch of those quotes, because you have the double quote over here and the single over there. Those are different. So it will match that. It's not a big deal. It's probably not going to cause too many false positives unless you have, some string that happens to have, one of these quotes inside of it. I haven't found it to be a big issue, but I just wanted to call it out there. And then, the last section here is basically like, if you have to perform a more thorough search, like, let's talk, compliance reasons now, or maybe you just have a gut feeling, or like you just think something is really leaked, but you have to get it off your mind. So nothing is really going to beat a manual scan here, and that's coming up next here. Like, when in doubt, literally check everything manually, right? So if the stakes are high, especially if you think like a production secret or any type of secret that's sensitive is out there, then your last line of defense is just, you gotta bite the bullet and check every single line of every file. And if your app isn't huge, this might not actually be too bad. Maybe you can crank through that in an hour or maybe a couple of hours, right? And although I will say, I think if it's going to be a couple of hours, I would suggest breaking it up into stages, maybe do 30 or 45 minutes at a time here, and then take a break, because that's going to give your brain a chance to reset, because this type of work is like really tedious. And it is way too easy to default to quickly scanning things, because your brain convinced you, like, there's no leaked secrets. We've been through 5,000 lines already and there was nothing. So your brain is like working against you in a good way, because it's really good at identifying patterns, and it's like, there's nothing. So before you know it, you're just like quickly scanning things. So like, definitely don't want to be this guy, right? This guy is just, people are getting in pretty easily there. And, that's going to make all your efforts go to waste, because if we're talking compliance and there's like legal reasons or whatever, like, you really need to be thorough about this. So really, I would suggest taking breaks here. And the rest of this is whatever. I'll fill these things in later. But yeah, I feel like that was a long video, but it is going through all things that at least I look out for. when I am trying to identify and fix leak secrets in a code base. So yeah, let us know in the comments below, like what are some of your best tips and tricks to identify secrets or passwords or anything like that? Am I missing something? Do you have a better way to do it? Let us know, because I think we'll all benefit from something like that. If you liked the video, please give it a thumbs up because it really does help a lot. Thanks a lot for watching, and I'll see you in the next video.